Hey everyone and welcome. Today we're going to do something a little different. We're going to decode the official Azure DP-100 certification, but we're not just going to look at it as an exam. Think of it as a map, a guide to what a cloud data scientist really does day to day. So let's start our day in the life and see what this job is all about.
I mean, really, you hear the buzzwords all the time, right? But what are the actual tasks? What problems are they trying to solve from the moment they grab their morning coffee?
So, here's our plan. We're going to use the official exam questions like they're little real-world scenarios. Each one is like a ticket, a challenge, a decision that an actual data scientist on Azure has to make. It's honestly the best way to see the job in action.
All right, so to kick off our day, let's just check out the official job description. What does Microsoft even say this role is supposed to be?
Think of this list as our to-do list for the day. Seriously, each one of these points is a major task we're going to tackle, from setting up our digital office and wrangling messy data, all the way to launching our final product and playing with the latest AI tools. This is the whole shebang.
Okay, coffee's brewed. First things first. You need a place to actually write your code and run your experiments. And in the cloud, that's not your laptop. It's a virtual space. And that's where this comes in, a compute instance. It's basically your own personal, secure workbench in the cloud, and Azure manages it all for you. It's where you'll fire up your Jupyter notebooks and do all that initial digging. It's your home base for the project.
Okay, workspace is set up. Now for the real deal. Data science, big surprise, is all about the data. But it almost never shows up looking all clean and perfect. It's time to roll up our sleeves and get our hands dirty.
So here's a super common task. The data you need is just sitting in a file on some website. How do you pull that into your Azure pipeline without a massive headache?
And the answer is the Import Data module. It's a tool built specifically for this, right inside the Azure ML Designer. You literally just give it the URL, and it does the rest. The big idea here is efficiency. On a real project, you don't build everything from scratch. You use the right tool for the job to get it done fast.
And here it is. Probably the #1 problem in all of data science, messy data. In this case, you've got holes, missing values, that are going to cause your model to totally freak out if you just ignore them. So, what do?
Well, there isn't just one right answer here. It's all about trade-offs. You could replace the missing numbers with the median value. That's a great move because the median isn't easily fooled by a few crazy high or crazy low numbers. Or, if you've got tons of data and just a few bad rows, you could just delete them. It's a judgment call you have to make based on your specific situation.
All right, our data is clean, it's ready to go. Now it's time for the science part of data science. This is where we pick the right algorithm, we train our model, and then we test it like crazy to make sure it actually works. Okay, let's tackle a really specific challenge, language translation. This is tricky, right? It's not just about knowing words, it's about understanding the sequence, the context. So the kind of neural network we choose here is absolutely critical. So could we use a CNN? Nope, not a chance. CNNs are amazing for understanding space, like finding a cat in a picture. But language is all about time and sequence. It's just the wrong tool for this job. Okay, what about a GAN? Again, that's a no. GANs are incredible artists. They create things like brand new, realistic photos. They don't translate things that already exist. And that brings us to our winner, a recurrent neural network, an RNN. These are built from the ground up to work with sequences. They have this kind of memory. They use what came before to understand what's coming next. That makes them perfect for something like language. And look, just training the model isn't enough. You have to validate it to make sure it didn't just memorize the answers. We do that with something called k-fold cross-validation. Just imagine chopping your data into 10 pieces, training on 9 of them, and testing on that last one. Then you repeat that process for all 10 pieces. That's the gold standard. Using just one fold, that's like letting a student grade their own test. It proves absolutely nothing.
Yes, we have a trained model. We did it! But a model sitting in a notebook is just a cool science experiment. To be actually valuable, it needs to be deployed so that other apps and other people can actually use it.
This right here is the fundamental recipe for pretty much any supervised learning model. First, you train it on data where you already know the right answers. Then you score it by asking it to make predictions on new data. And finally, you evaluate how well it did with a metric like AUC. It's the core loop: train, score, evaluate.
And to get that model out into the real world, handling live predictions, the go-to service is Azure Kubernetes Service, or AKS. It's built for scale, it's built for reliability, and it makes sure your model can handle all the traffic the real world throws at it.
But the day's not over yet. A real professional data scientist has to think bigger than just the model. They're thinking about cost, they're thinking about ethics, and about using AI responsibly.
So what's with the giant 0 on the screen? This is one of my favorite pro tips. It's the ideal minimum number of nodes you should set for your compute cluster. Why? Because when it's not being used, it can scale all the way down to 0, which means it costs you 0. It's a super simple but really powerful way to manage costs.
And this gets to a huge professional responsibility. Differential privacy is this amazing technique that lets you share insights from data without revealing anyone's personal information. You do it by adding just a little bit of strategic noise. The key thing to know is this epsilon value. A lower epsilon means more noise, which means stronger privacy, but it might make your model a little less accurate. It's a really important balancing act.
So, when you put it all together, this is what a modern data scientist looks like. They're an architect, designing their whole environment. They're a detective, exploring the data for clues. They're an engineer, building and deploying models. And now, they're on the cutting edge, tuning these huge language models with advanced techniques. It's a role that's a true mix of science, engineering, and a whole lot of responsibility.
And that leaves us with maybe the most important question of the whole day. It's one thing to build a model that's technically accurate, but to build one that's fair, that's unbiased, that's trustworthy, that is the real challenge. And that's the ultimate goal of being a true professional.